Hey guys, this is Mac Kids and One with Mac Programming Lesson 2. So, this programming lesson isn't going to be about polishing your application or GUI stuff. It's going to be about understanding. Because basically, I watched a bunch of partners' videos and professional YouTube videos on how to program. And it seemed like after watching their videos, you might actually be able to make a good application all by yourself. But you may not necessarily truly understand what's going on. And understanding what's going on in things like C and Objective-C is something that takes a long time. I've been doing C for almost a year, and just a month ago I actually started to understand what I'm actually doing. By now I pretty much get what's going on. And so, as I'm not the best teacher ever, I'm going to try my best to pass the information along, but you may not catch the drift. So, this is hard. But I'm going to be using a terminal application to get you guys to really understand what variables are and what pointers are. Because in, say, Java, it's pretty easy to understand. There are no stars, there's no, nothing. A variable is just a variable, and you can use dots to do stuff with it. But with this, I have to teach you guys what you're actually doing. Because in Java, there is no, what you're actually doing, because you don't have that kind of power. So I'm going to make a new project, and I'm going to go under Command Line Utility, and I'm going to click Foundation Tool, and I'm going to call it Plain Old Learning, just to represent we're just learning stuff. There's nothing new. And so you'll notice under Source, there's one .m file, which is plainoldlearning.m. This is where we're going to put our stuff. So let's start from the ground up. Right here is a C function. This is how you normally would declare a function in C. It's variable type space, thingy space, left parenthesis, parameters, right parenthesis. And at the top there's an import. What this import does is it uses the foundation library, which has things like NSString in it. So now from there, you might notice that nslog takes something that starts with @ then two quotes, and inside of that quotes can be whatever you want. Whenever you put an @ before quotes, it knows that you want to put an NS string there, and it converts what's inside of those quotes to be an NS string, which people didn't understand. @ is like a magic character in Objective-C, especially this version of Objective-C, that will tell everything, basically, that you want to make an NS string or you're going to synthesize something. It's really an important thing to notice. If you get rid of the @ then it thinks you're just giving it a character array, because this is, of course, C, and in C you declare a character array with quotes. So that's not exactly how this is going to roll. I'm going to get rid of this nslog. We're going to ignore that for now. And we're just going to type in between this NS auto release pool and pool drain. So right here, first of all, when you're declaring a string in Objective-C, the class name or variable name is NSString. Then you do a space, and then normally you do the variable name in Java. But you know to do a star somewhere between the variable name and the variable type. So I'm going to make an NSString foo. And we have to do that star there, but you're not exactly sure why. The star means that I'm not going to specifically own foo. All foo is going to be is a little number that represents some place in my RAM, in my memory. So foo, in this case, since it's a 32-bit application, will be 4 bytes, and that's 4 characters, or 4 numbers. So foo is going to be 4 numbers, and that tells the computer where in memory. All of the memory can be represented by 4 different numbers. So foo is just going to point to something else. So when we say foo equals, we're just going to be changing the 4 numbers that it is, not what's actually in it. So say I do foo, NSString foo equals, then I'll do left bracket, NSString alloc init. Now first of all, NSString alloc means we're going to make a new place in memory that's going to have an NS string. And what that'll return is that'll return a 4-digit number that is the location of it, or an NS string star in this case, representing a pointer. So we're making the pointer foo point to a new NS string in memory, and then it just initializes this string, makes it an empty string and stuff. So let's just say, we can say NS string alloc init with string. And now it's going to be quote hi quote with an at before it because it's an NS string. So now there's going to be some NS string somewhere in our RAM that's going to be hi. And foo is going to be like the address of where that is. So let's say I want to know where that is. I'm going to use nslog to print out a pointer. To do that, you do %p inside the quotes, and as the next parameter, you do the pointer. So foo is a pointer. So what it's going to do is give us a, in this case, it's going to be an 8-digit hexadecimal thing, but when it converts it to a real pointer, it's going to be 4 digits. So I'll open up the console, and I'll run this, and we'll see our nslog will print out the actual place in memory where foo is. So foo is at 2030. So that tells the computer everything it needs to go. It zips to that place in memory whenever you're accessing foo. Now the thing is, say I make another NS string called bar. And I'll make that another NS string alloc init with string hello. And let's say we do another nslog down here to print out where this NS string is. So now we'll have the address of both strings. So hi is going to be at your address 2030, or foo in this case, and bar is going to be 2040. So 2040 and 2030 technically mean nothing. They're just telling the computer where this data is actually going to be on the computer. So now let's say we say foo equals bar. Right down here. We say foo equals bar. Now foo will have the same address as bar. As you can see, foo is at the same place. So when you assign things that are pointers, like star, you're actually just assigning the address. So in this case, we're assigning foo to point to where bar is. Now, the NS string that is hi is still at 2030. We just have no way to access it now, because foo originally was telling us where this NS string is right in memory. But if foo is no longer telling us that, it's just telling us where this NS string is in memory, then we have no way to access foo in any way. We no longer have control over this NS string in memory. It's just a waste of memory. And that's called a memory leak, where your program leaks memory and no longer can access this piece of memory that's now being wasted until the program closes. So let's say we want to fix that. So what we're going to do is, it's pretty easy. What we would do, we can make another NS string star foo temp that we're not going to replace in any way whatsoever. So foo temp at the beginning, if I just nslog it, will be pointing to nothing. It's an empty pointer. So it may or may not give me an error. I'm not so sure. Okay, so it's at 0x0. So it's at nothing, 0. But if I assign foo temp to be foo and foo to be bar, now, here's what we do. Foo temp is going to be pointing to where foo was pointing. So it's going to be pointing to 2030. Now foo is going to be pointing where bar was pointing. Bar was pointing to 2040. So now we have two things pointing to the same thing. Why does bar have to be pointing to this little thing? What we can do to make bar no longer point anywhere, we can just say bar equals nil. And that may or may not be correct. Yeah, so now bar is pointing to nothing. Bar is no longer there. Now, if we didn't assign something else to have control over bar, so let's say we did something like didn't assign foo to be bar, and then we said bar equals null, then this ns string that's going to be hello is going to be there in memory still, but we have nothing pointing to it. So I'm just going to do a cut here, and we'll go on to part 2 so I can explain this in more depth.